All right, here's a little harder problem. This is number 43, optimization section. So it's section 3.7 in the book. And we're going to optimize. This time it's a very interesting problem. We have a round log here. You know, it's perfectly circular log. The diameter is 20 inches, so the radius is 10 inches. And what we want to do is we want to minimize, or maximize rather, the strength of this log. We're going to cut a beam out of it, you know, a square or rectangular piece of a beam out of it. And we want to know what dimensions we should cut the beam to maximize the strength. And we happen to know that the strength of the log is proportional to the height squared times the width. So this, you know, we're going to be applying a force on it in the downward direction. So the height is going to be particularly important. It's to the second power. The width is to the first power, and we want to maximize the strength of this beam. So what dimensions do we cut out of this log, out of this circular log? And here's our equation. We want to maximize that. K is a constant, so that's okay, but H and W are both variables. But because they're in a, you know, in a circular log, they're related, and they're related by this fact. By the diameter is going to be 20 inches, so W squared plus H squared is going to equal 20 squared, right? So we're going to write an equation like that. Let's see, H squared plus W squared is going to equal 20 squared, just by the Pythagorean theorem. And then we're going to solve for one of these, and I think it's probably easiest to solve, well, I wonder, it might be easiest to solve for H because we're going to square it. So if I take W over to this side, I end up with this. H squared is equal to 400. Let's write 20 squared as 400 minus W squared. So we can take this thing right here and put it in for H squared, right? That whole thing is H squared now. So we get a new equation that looks like this. So our strength equation is going to be K, a constant, times 400 minus W squared times W. Okay, so we always do that. We always follow that process. We write the equation we're trying to maximize or minimize. If it's got two variables in it, we have some kind of a relation that we can eliminate one of those variables. So we get the equation down to where it just involves one variable. And simplify this, you know, simplify as much as possible. So S is going to equal K, well, let's write it like this. 400 K times W minus K times W to the third power, right? And now we can differentiate that quite easily. So S prime is going to be, this is a constant, K is a constant, so this is just going to be 400K minus, here we're going to bring the 3 down, so it's going to be 3K W squared. That's the first derivative, and we're just going to make that equal to 0, find the critical points. So this is going to equal 400K is going to equal 3KW squared. The K's are going to cancel, so the K, you know, really has nothing to do with it at the end. You know, you can see that that's a constant of proportionality tells you how strong the log is, but it really doesn't have anything to do with, you know, what dimensions we should choose to maximize that strength. So we take the divide by 3 and take the square root of that. So W is going to be 400 divided by 3, and then take the square root of that. So W, let's see, what would that be? 400 divided by 3, take the square root of that. About 11.55 inches. So the width should be about 11.55 inches. And then we can put that back into here and figure out what the height should be. So H is going to be the square root of 400 minus 11.55 squared. So the height should be 16.3 inches. So very interesting, right? We make the height a little bit bigger than the width if we wanted to bear weight in this direction. And we should check to see that this really, that, you know, we have a maximum here. We're trying to maximize the strength. So we take that first derivative and we differentiate it to see what the second derivative does, okay? So here's S prime is 400K. Remember, K is a constant, so it's, you know, it's just like another number. Minus 3K W squared. So differentiating that, S double prime is going to be the 400 goes away. We bring the 2 down, so I get 6K W to the first power. And as long as W is positive, this is going to be a negative number. So this is going to be some number less than 0. Negative number, of course, means that we have a concave down function. So this is going to be a maximum. So that just verifies we've found the maximum. So that's a little bit more involved problem. Very interesting, very, very powerful conclusion.